Let's talk about how to solve word problems. My examples will come from algebra, but this could apply to, physics or calculus or other areas as well. I would have to guess that most people struggle when they first learn to solve word problems. And the issue typically is not the underlying math. I mean, you're used to things like this. If somebody says x plus 5 equals 23 and says find x, you probably can do that. The problem with word problems is people don't know how to take what's written up in a verbal form and turn it into this. So let's look at some general tips that you could apply. All right. Let's start with the thing that you may or may not like. And that is, in most cases, you need to have some type of domain knowledge. What does that mean? Well, you have to know something about what the word problem is describing. That is, if it's a problem that's about physics, then you may have to know the relevant equations in physics. So let's say you were given a problem. You were told, and maybe even given this diagram. You have a voltage source. You have this electrical circuit, has here what we call a resistor. And you're asked to find the current. So the resistor is in ohms actually, but we'll put R. And you have the current I. And so if you're given V and you're given R and told to find I, what do you do with that? Well, you need to know that the relevant equation is V equals IR. If you know that, well then solving for I is easy if you're given the other two. In fact, solving for any of these is easy if you're given the other two, right? But if you don't know this, what are you going to do? In most cases, you're going to find it very difficult to solve that type of problem. So you typically have to know something about that. And that's also the reason why when you're given word problems initially in algebra, they involve things like rates and maybe integers. And that is a relationship between numbers and maybe mixtures and things like that, right? Something else to keep in mind, units. If somebody says Bob has 3 apples, how many apples does Bob have if you give him 2 apples? You're probably used to doing something like this. 3 plus 2 equals 5. But in reality, it's this. 3 apples plus 2 apples equals 5 apples. So what difference does it make whether I use this or this? Well, one of the ways that units will help you is it helps you check the units to make sure the expression you wrote is correct. So let's say you're given this problem. You have a rate here, 60 miles per hour. What is that in miles per minute? Right? Start with this. Normally we write like this, 60 miles per hour. Okay? And then if I need to convert, what do? Well, I know, and I'm trying to go from hour to minutes. I know 1 hour equals 60 minutes. If I were to divide both sides by 60, then I would get 1 is equal to 1 hour per 60 minutes. If I were to divide both sides by hours, I would get 1 is equal to 60 minutes per 1 hour. So which one do we use? Well, first of all, why do we even use it? Well, when I'm multiplying by 1 hour divided by 60 minutes or 60 minutes divided by 1 hour, there's still essentially 1. So just like any other time, you can multiply by 1 without changing the underlying answer. Right? I mean, you change the form, we're changing the units here, and it will change the quantity associated with those units, but it's not going to break the equation. So what do we use here? Well, either of these could be correct in the right context, but I have to make it work for this particular problem, which is miles per hour. So let's look at this. So if I have 60 miles per hour, and I multiply by 1 hour for 60 minutes, The denominator has hours, or hour. Here it has hours. These cancel out. Okay, just like they would if I had a 3 here and a 3 here. I can cancel out. And that leaves us with 60 miles per 60 minutes. And typically then I would reduce this just to 1 mile. Per minute. I never keep track of, am I supposed to be dividing by 60, which is essentially what you're doing here, and multiplying by 60? I just redo this each time. Because what if we had made a mistake? 60 miles per hour times 60 minutes per hour. Well, then I'd get, 60 squared or 3,600 mile minutes per hour squared. Well, I don't even know what that means, really. Okay, so this isn't really what I want. And in fact, the answer told me it was miles per minute, so the first one conformed with that anyway. But by checking the units this way, I know this can't be the correct answer because they have to work out. Okay? And so one last thing. I like to take the sentences that are in the word problem. We'll put this number 3. I like to take the sentences in the word problem and write down the corresponding relationships. So convert sentences to mathematical relationships. Right? So what do I mean by that? Well, the problems you're typically given in a class, this wouldn't necessarily be the case in the real world because you have to figure out everything there. But the problems you typically see in a textbook almost always give you all the information you need, other than they may leave out the relevant domain knowledge. They just assume that you understand distances and rates and things like that. Okay? So they typically give you what you need. So let's say we're given a word problem and we're told to find, we would have some other stuff, but we're told to find, something about the relationship of A to D. Okay? Well, if I look through the sentences, in the first sentence I get that it can be written as A equals 2B. And the second sentence I get that, B is equal to 3C. And then in the, the third sentence I get that, C is equal to 1/4 of D. Well, then what can I do? Well, I need to get from A to D. So I have A is equal to 2B. And now I know B is 3C. So this becomes 2 times 3C. And now we know C is equal to 1/4 D. So this is 2 times 3 times 1/4 D. Then I can work this out. And here I go from A to D, and that allows me to answer the question. So it's like figuring out a jigsaw puzzle. I go from one part to the next, to the next, to the next. Of course, all these things I'm saying are generalities. For the particular problem, you just figure out which parts are relevant, which parts you don't really need to know as much about or whatever. But that's the basic idea. So let's put that to use, solving a problem. So this is the type of problem you might see in a textbook when you first learn word problems. Bob is twice as old as Alice. In 5 years, Bob will be 1.5 times as old as Alice. How old is each? So I'm talking about Bob's age and Alice's age. Okay, I kind of understand something about ages. Okay, so let's do this. Let's say let B equal Bob's age. And just to be clear, I'm going to write over here in parentheses, in years. Because maybe there's something in the problem that's not true here, but something in the problem says I have to maybe do a conversion between something, right? And A is equal to Alice's age. Also in years. So these are the two variables, at least, that I know I need right now. So what do I do with this? Well, look at the first sentence. Bob is twice as old as Alice. So what's the relationship there? Well, twice means 2 times. So I think the relationship is B is equal to 2 times A. Usually at this point, I'll spot check. Because in English, I don't typically get confused about the relationship here. But when I'm transferring it to the mathematical relationship, it's easy to make a mistake. So I might sort of spot check. Meaning I'm just going to throw in something and see if it kind of works out. So maybe for a spot check, if Alice is, say, 20 years old, and really these are years old, right? Then Bob will be what? 2 times 20 equals 40 years old. Does that match up with the English here? Bob is twice as old as Alice. Yeah, 40 is twice 20. I'm just doing this so that way I don't accidentally write this, that I see twice and think, oh, it says 2B equals A. So that's the reason why I check this. Okay? So here's my first relationship. In 5 years, Bob will be 1.5 times as old as Alice. So B was a number of years. Now we're talking about B plus 5. And it says in 5 years, Bob will be, so the B, we're having equality here, be 1.5 times as old as Alice. That's 1.5 times as old as Alice in 5 years. So 1.5 times A plus 5 years. Going back to what I said earlier about units, do these work? B in years, 2 times years is still years. Years plus years, these would be years. So all the units match as well. So now it's just a case of solving these expressions. Okay? Now, if you know anything about a system of equations, you could solve it that way. Okay? Because each of these represents a line, and even though this won't be the correct plot, what you're really doing is something like this. Maybe you have one line here, and you're trying to find the common solution for A and B that satisfies both relationships. Okay? The easier way is just to do a substitution similar to what I did a moment ago. So let's take the second equation. B plus 5 equals 1.5 A plus 5. And now everywhere I see B, let's put in 2A. So 2A plus 5 is equal to 1.5 times A plus 1.5 times 5. There's no B's over here, which is equal to 1.5A plus 7.5. And these are still in years. So I'm going to take this part and this part. And now this gets 2A minus 1.5A is equal to 7.5 minus 5, which is equal to 2.5. And this right here will be 0.5A is equal to 2.5. So A is equal to 2.5 divided by 0.5, which is 5 years old. That's Alice's age. And now we take this and go back to this expression and get that B is equal to 2 times 5, which is 10 years old. Does that work? Bob is twice as old as Alice. Well, yeah, 10 is twice 5, so it works for the first expression. What about the second one? In 5 years, then we have B plus 5 will be 15 years old. And A plus 5 will be 10 years old. Well, 10 times 1.5 will be 15. So that's correct. Okay? So these are just some ideas, but like I said, if you know nothing about the problem and can't sort of figure something out, then you're probably going to be stuck and not be able to solve it. All right? Writing down units, at least to make sure that the equation's in the right form, can be very helpful. And then my third thing was writing out the mathematical relationships and going through and figuring out how they fit. Because even though I wrote these in order, maybe the way I really got them was like this, C is equal to 1/3 B, and then I got, C is equal to 1/4 D, and then finally I had A is equal to 2B, and I had to put them in the right order to figure out this is what I have. So I'll make some more videos on specific types of problems. But those general ideas are something to keep in mind. All right?